Hello everyone, today we are talking about section 12.3, which is what we call arithmetic sequences in series. It is pronounced arithmetic. I know it looks like arithmetic, but when we talk about sequences in series, we pronounce it as arithmetic. So we have arithmetic sequences in series. So what we're going to do in this section, we've already talked about sequences, we already talked about series, but now we're going to look at them slightly differently. We're going to focus on just one specific type of both of those things. And when we focus just on that one type, there's certain things that we can do that we weren't able to do before because we didn't have some kind of crucial information that we need. So let's start with what makes an arithmetic sequence or series. So in order to be arithmetic, it needs to be a sequence or series. So either a list of numbers or a bunch of numbers added together. So it is a sequence or series, that's where we add them together, whose terms differ, that's the important word, by a constant amount. Okay, now what that means is that to go from one term to the next, I'm always moving the same amount. So between my first term and second term, I might have like 3. So I'm adding 3 to the first term to get to the second. Then I'm also adding 3 to get from the second to the third to the fourth to the fifth, and so on. That amount stays the same every time. Your terms might change. Actually, your terms will change. But it is a constant amount. And that could be also negative and make the sequence go smaller. What this really is referring to is what we call a linear pattern. Okay, this is kind of what we've been referring to. These are the ones that have that adding or subtracting pattern to them. If you want to make that note here. We can also talk about common difference. Common difference is going to be something that we use a lot. So we do give it a letter. We give it a lowercase d. So lowercase d is going to refer to the common difference. This is the amount that terms differ by. Okay, and it's called the difference because it can be found by subtracting. Again, difference means subtraction. So we're subtracting terms. Okay. With our arithmetic sequences, we can think of these, we've kind of already said this, as a linear function with sequential natural numbers as your domain. So sequential natural numbers just means I'm going from 1 to 2 to 3 to 4. Basically, those would be my term numbers. I start with 1 and go all the way up as far as I want, counting my whole numbers. Okay, so we're going to think of these with linear patterns. Now, before we were using that equation y equals mx plus b, we're not going to use that equation anymore. We're going to get a new equation that we'll talk about here in just a minute. Before we do that, though, one of the big things we're going to talk about now is how do we decide if something is arithmetic or not? Because if I can know that it's arithmetic, then that formula we're going to get to is going to be helpful for us. But if it's not, it still doesn't work. So what we need to do is we need to figure out, is there a constant difference? If we can find the constant difference, that means that it is arithmetic. So is it going up or down by the same thing every time? So if I look at 1a here, I'm going from negative 10 to negative 4. Well, I can subtract those. It's negative 4 minus a negative 10, which gives me a positive 6. Okay, and we can also see that. I'm adding 6 to go from a negative 10 to a negative 4. I'm also adding 6 to go from 4 to 2. I'm also adding 6 to go from 2 to 8. And from 8 to 14 is also adding 6. And you do want to make sure you go through all of those because sometimes I'll throw one in at the end that breaks that pattern. So you got to make sure you check them all. So this one does have that constant difference. So we are going to say that this is arithmetic. Okay, and if we look at our instructions here, our first part was determine if it's arithmetic, and if it is, we need to find the constant difference and the next term. Well, the constant or the common difference is what I already found here. So my d is going to equal the 6. That's what I'm changing by, that positive 6. And then the next term is going to be what comes after the 14. Well, if I follow my pattern here, I would add 6 to 14, which gives me my next term of 20. Okay, we can also talk about example 1b. If I look at this one, I'm going from negative 2 to a negative 5. That means I'm going down by 3, so I'm subtracting 3. From negative 5 to negative 11, I'm going down 6, sorry. Which even just there, I can now see that I don't have a constant difference, but if I keep going, I'm going to go down 9 and then down 12. So I'm definitely changing on each of those. But I'm not changing by the same amount. So we would say that this one is not arithmetic. Okay, and because it's not, I don't have to worry about the difference because there's not one, and I don't know what the next term is going to be because I don't know if this pattern is going to continue or if there's something else going on. So we don't have to worry about the second two pieces if we say that it's not. Okay, let's get to our formula here. So when we start to talk about our arithmetic sequences, we're going to get what we call a general rule. Now this general rule is going to be used to find any missing terms. So any question where I ask you to find a missing term, this general rule is what you want to use. Now, when we've done this before, earlier in this chapter, in 12.1 and 12.2, if I asked you to find terms, you started to use the equation something like y equals mx plus b. Now, we're going to still use that, but we're going to change it slightly. When we use this y equals mx plus b, we had the change went in for m, and b was our starting value. But that was always a tricky thing because it wasn't actually a number that was given to me. I had to go backwards and kind of fix that by going back to that 0th term is what we referred to it as. We're not going to have to do that anymore. In this formula, this is going to have a different way to fix this. So what I have here is I have a sub n. Okay, this is typically the term we're trying to find. I'm not going to label that though, just because sometimes it's not. A sub 1 is something you should be familiar with at this point. This is your first term. Okay, n in the middle here is your term number, and that's the term number from a sub n. So whatever term this ends up being is the term number that I plug in for n. So those two n's that are there, both the red ones, are the same number. Whatever I put in for a sub n, I have to put in here. Whatever I put in for the n for a sub n. Then I have a minus 1. That one just stays. And then d here. D is that common difference again. Or you can think of it like your change. So let's talk about how this is a little bit different. Your starting value is now out front. So I've kind of written this as b plus mx. Your n, your change is now at the end. We call it d. And now I have this n minus 1. Now this n minus 1 shifts our sequence off one place, which is just another way to deal with the fact that our terms were off when we didn't use that 0 term. So it's just a different way to fix it than what we did with y equals mx plus b. But this formula tends to be a little bit easier because you have places to put everything, and all of the numbers that you need to plug in here are given to you either as part of the problem or as part of the sequence or series that they give you. So all of the pieces that you plug in should come from the problem. Excuse me. You should not have to be making up any of these numbers to use or trying to find them. They're all going to be a part of it. Okay, so let's explain what I mean there. If I look at number 2 here, I want to find the 12th term. So I'm trying to find the 12th term of the arithmetic sequence. I do know it's arithmetic, and that's really important because if I'm not told that it's arithmetic, I cannot use this equation. So I have to be told that it's arithmetic. Once I do, I'm good to go with this equation. Then I can look at my sequence here. I have 20, 14, 8, 2, and negative 4, and then it keeps going from there. Well, if I look here, I can start to identify my pattern and that difference that I have. It looks to be like I'm subtracting 6, and that subtracting 6 goes through my entire sequence. So I know that's going to be my difference. So if I start to look at my equation, I have a sub n is equal to a sub 1 plus n minus 1 times d. I want to plug in everything that I know or everything I'm trying to find. So I'm going to ignore a sub n a second. I'm going to start with a sub 1. A sub 1 is my first term, so I plug into 20, plus, I'm not quite sure what n is yet, so I'm not going to write that, but I do have a minus 1, and I have my difference. My difference is the negative 6. So I'm going to put it in parentheses just because it's negative, but really it's just being multiplied on the end there. So now I have this couple missing pieces here. I have the n and I have the a sub n. Now these two are definitely connected. We kind of talked about that up here. And I'm trying to find the 12th term. Well, the 12th term is where I find a sub 12. So that's what I'm trying to find, but now I just chose my n because I just made n here 12, so my n that goes into the other side of the formula is also 12. Now if you look at what I have on the right hand side, I have all numbers. So this simply becomes an order of operations problem and just simplifying using PEMDAS. As long as I can do that, I'll have my 12th term. So let's go ahead and try it. A sub 12 is going to equal, if I use PEMDAS, I have to start in parentheses, specifically inside the parentheses. So I'll do 12 minus 1. So this is 20 plus 11 times my negative 6. Well, next thing is multiplication, which is the 11 and the negative 6. So a times 12 is equal to 20 minus 66. Then from there, I can subtract the 66, and I get that a sub 12 is equal to a negative 46. And that is my 12th term. Now, real quick before I go on, some of you are looking at this sequence and say, well, I'm at a sub 5. Couldn't I just keep subtracting 6 until I get to 12? Yes, you could. However, it's very hard once you start to go more than 2 or 3 places to remember which one you're on. And even if you're super careful, that can get very complicated. I will also tell you right now, I'm expecting you to use the formula. So when you get to the quiz and some of the homework questions, I'm not going to ask you terms that are very close. I might give you something like this and then ask you for the 100th term. Okay? You're not going to want to count all the way up to the 100th term. Use the formula will get you there. That's what I'm expecting you to do. So yes, you could do the shortcut, or not a shortcut, but do it the other way. But really your equation here is going to be your shortcut. Alright, let's talk about example 3. Example 3 says find the missing terms in the arithmetic sequence. I have 17, and I have a bunch of blanks, and then I have a negative 7. Now I say there's a bunch of blanks, but those number of blanks is actually really important. What I need to figure out is what is my pattern, because if I know my pattern, I can fill in everything else, excuse me, to get from 17 to a negative 7. And the number of kind of jumps that I make along the way is important. Now, I told you that if we're finding missing terms, we're going to use that equation. So I actually am going to still use the equation. I'm going to use a sub n is equal to a sub 1 plus n minus 1 times d. So I need to find, basically plug in everything I know. So let's actually look at what I have. I know that 17 here, that's a sub 1. And if I count over here negative 7, that's going to be a sub 5. Okay? And the reason I know it's the 5th term is because of the number of blanks. I would have my 1st, 2nd, 3rd, 4th, and then 7 is negative 7 is going to come in the 5th place. So I can use that as my extra term for a sub n. So I'm going to plug the negative 7 in there because that's the term value. Then I'm going to plug the 17 in for a sub 1. Plus my n is the term number of the extra term that I used, not the first term, but the other one, which is the negative 7. That was a sub 5, so I'm going to plug in 5 minus 1 times d. And now again, we need to solve. Now this one's not going to be quite as easy because I'm trying to solve for d, but I can start to work through this. I'll start with 5 minus 1. So this is negative 17 is equal, or negative 7 is equal to 17 plus 4 times d. Now to solve for d, I need to subtract a 17 on both sides, which gives me negative 24 is equal to 4d. Then we'll divide by 4 on both sides, and d is going to equal negative 6. Okay, well now that I know that it's negative 6, that means I'm applying a negative 6 to every one of these terms to get to the next. So from 17, I need to subtract 6. Well, that gives me 11. Then I need to subtract 6 from the 11, which gives me 5. I can subtract 6 from the 5, which gives me negative 1. And then I always still do the last one just to make sure that this works out. I get negative 1 minus a negative 6, or minus 6 does give me a negative 7. So that one checked out. Those 3 are my missing terms in the middle. Okay, so we're using the same equation, but we're using it in some different ways. Okay, and if we go to the back of this, the next page, we're going to use it in an even different way to try and work through this. And we're actually use it 2 different ways in the same problem. So this can be a little bit confusing, but it all depends on what I have. So I know I'm finding a missing term. I'm trying to find a sub 5. The problem is they're giving me 2 terms, a sub 8 and a sub 14. In order to find the 5th term, a sub 5, I need to know 3 things. I need to know the first term. I need to know the term number I'm trying to find, which I already have as the 5. And I need to know the difference. I don't know the first term, and I don't know the difference. So I have too many missing pieces. So what I need to do is I need to try to adjust my formula slightly so that I can actually use the terms that I have. So what I'm going to do here is I'm going to say that a sub n is equal to a sub 1 plus n minus 1 times d, the same formula that we were working with on the front. Now what I'm going to do is I'm going to try and find d first. Hey, the reason I do that is your arithmetic sequence is more or less defined by that difference. And so if I know that, that's going to help me more than anything get to that term. Okay, if I needed to, I could just start taking it away from the 85 and getting to this fifth term. I'm not going to, but you could. So let's use the two terms that they did give you. I'm going to use the bigger one, the 14, as the a sub n. So this is going to be a sub 14, which is, 157. So I'm going to go in for a sub n. Then I don't have a first term, but I do have a smaller term. So I'm going to use a sub 8 here. I'm going to plug in the 85. Now, the problem is now in the parentheses here I have to adjust because I didn't really use the first term. That n is still going to be the same because I used the 14th term for a sub n. So that needs to be 14. But this 1 here is the issue. I didn't really use a sub 1 here, and that doesn't match the 1 that I have here anymore. I used the 8th term. So the term number that I use is what I need to subtract here. So now instead of subtracting 1, I'm going to subtract 8, all because I used the 8th term here, a sub 8, instead of the first term. Okay, by doing that, I can now find the difference because I have everything filled in but d. So now we're going to solve this the same way we did the last one. I'll take and do the subtraction on the inside of the parentheses first. Okay, 14 minus 8 is going to give me 6, so this is going to be 6d. Plus the 85 is equal to 157. We'll subtract the 85 on both sides, which gives you a 72 is equal to 6d. I can divide by 6 on both sides, and I get that d is equal to 12. So now I'm partway there, because remember I'm trying to find a sub 5, and I had two issues. I didn't have a first term, and I didn't have d. Well, now I have d, and I also already fixed that first term problem. Remember here that I plugged in something else for a sub 1. So I'm going to do the same thing. I'm basically going to use this first line here, but I'm going to take out the 14th term, and I'm going to use the 5th term instead. I also now know d, so I'm going to plug that in. So I'm using a sub 5. Then I'm going to have the 85, plus I'm not using 14 anymore because I switched to the 5th term. So I'm going to plug in 5, minus my 8, because that's the term that I plugged in for the first one, and I'm going to multiply that by 12. Okay, if we go ahead and simplify there, I'm going to start in my parentheses. 5 minus 8 does give me a negative, but that's fine. It is a negative 3, so I have negative 3 times 12, which gives me a negative 36. So a sub 5 is going to be 85 minus 36. Simply subtract that, and you get that a sub 5 is equal to 49. Okay, so we end up getting 49. Okay, hopefully that one makes sense. It's usually one of the trickier ones to figure out kind of what we did there, but make sure you just kind of rewatch that if you need to. Pay attention to how I took out a sub 1 and used a sub 8 instead, and so I had to switch the 1 to an 8. Last thing we need to talk about here, everything we've done so far is the sequences. We need to talk about the series. And really the difference when we talk about series is now I'm talking about sums. So I'm talking about adding everything together. Specifically, what do we get when we add the first so many terms together? Okay, and so whenever you see this word sum, we're going to be using this equation that sits over here. Okay, now this equation is just similar to the one that we have on the front, where all of the pieces should be given to us. Now, it's not quite that easy. Sometimes we will have to do a little bit of work to find a term as well, and so we may have to do that. So let's just get started with our first example here and see if we can use this formula. Okay, I think we're going to be familiar with all these pieces, so we'll just go ahead and get started. So I'm starting to find S sub 18. Now this 18 means I want the first 18 terms. Okay, so I am trying to find the sum of the first 18 terms. Now to do that, I'm going to start to use my equation of S sub 18. Well, if I use my equation, n, I just switched out for the 18. So that's going to be what goes in front of the parentheses here. Then in the parentheses, I have a sub 1, which is my first term, which is the 13, plus, I'm going to hold on a second and divide by 2. Now, I pause for a second here because I need a sub n. Now, in this case, a sub n is a sub 18. And so the question I would ask you is, do we know the 18th term? And if you look, I only give you the first 4, so I definitely don't have it written for me. So I need to find the 18th term. So I'm going to ignore the problem that I have right now, and I need to find the 18th term for this series, or really I can think of it as a sequence. So now I'm going to go back to the other equation that I had, and find with a sub n, a sub 1 plus n minus 1 times d. I'm going to use that equation to find the 18th term. So I can try and set up this one. A sub 1 is going to be my first term, which is 13, plus my n is the 18, minus 1, times my difference. Well, my difference here is how I go from 1 to the next. So from 13 to 2, that's minus 11. Same thing from 2 to negative 9 all the way through. So my difference here is going to be a negative 11. And now I can simplify. So a sub 18 is going to be 13 plus 17 from the 18 minus 1 times the negative 11. So a sub 18 is going to be 13 plus a negative 187. That's from the 17 times the negative 11. I just did that in my calculator. Add those together, or really I'm subtracting them, and I get a sub 18 is going to equal 174. Okay, so, sorry, negative 174. So negative 174 is my 18th term. So I'm going to take this number that I just found, and I'm going to plug it in to my formula. So I get a negative 174 inside my parentheses there. Okay, now it just becomes, again, a simple order of operations problem. I just need to simplify through that. So this is going to be s sub 18 is equal to the 18 on the outside is going to be the last thing we do. On the inside, I really need to start at the top of the fraction and simplify that. So I'm going to do 13 plus a negative 174, which gives me negative 161. And I'm going to divide that by 2. Okay, now when I divide that by 2, I can do that in my calculator. I get 18 times a negative 80.5. Sorry, that should just be the whole parenthesis there. And then I can multiply that. Okay, and this is still for s sub 18. So s sub 18 is going to be 18 times negative 80.5, which is negative 1449. So the sum of the first 18 terms is negative 1,449. Excuse me. And so that's the way this is going to work, is you just need to set up your equation, work through it, and then you're going to end up with an answer at the end. Now, I do want you to just kind of make sure that the answer makes sense. A couple things to check. If you don't have decimals as part of the sequence, you shouldn't have decimals as part of the answer. Okay, so even though I had a decimal here, it ended up becoming a whole number, which is what I want. The other thing you can think about, too, is whether the sum should be positive or negative. Now, this sequence started positive, but then it went to negative, and it's going to continue to be negative all the way out to that 18th term. So I definitely have more negatives than positives, so I'm not surprised that my sum ended up being negative. Okay, those are just little things that you can kind of check to make sure that you didn't lose anything along the way in that formula. Okay, let's talk about B here. Now, B is the same question. I'm asking you for the sum still, so I'm going to use the same equation. I'm going to actually write the equation out for this one. The difference is just the form that I give it to you in. What I gave you in Part A is what we call a partial sum with a capital S, and I give you the sequence. Part B, I'm giving you sigma notation. This is more what we looked at in 12.2. So I'm going from 1 to 15. Well, that tells me how many terms I want, because that's the first 15 terms, because I'm starting with 1 and going to 15. The other thing that's different is I'm not given the exact sequence, but I am giving this formula. This is going to be my formula to find the terms. I won't need to go back and use what we did on the front, because they're giving me an explicit formula right here. So what I'm going to do is to start to find my first term, well, I just need to plug in 1, because that's the number that's on the bottom. So I'm going to plug 1 in for k. Off to the side here, I'm going to do that. So 5 plus 2 times 1. 2 times 1 is 2, plus the 5 gives me 7. So if I start to set this up here, I know I'm finding s sub 15 now. So I have 15 on the outside. A sub 1 is going to be the 7. I'm going to add to that a sub n. Well, that's now the 15th term, which is really taking the number on top and plugging it in for k. When I do that, I have 5 plus 2 times 15. 2 times 15 is 30, plus the 5 gives me 35. So we have 35 here. And again, divided by 2, that's just part of the formula. Then we go ahead and use that. So I do the 7 plus the 35. So this is 15 times 7 plus 35 is 42. And I divide by 2. Okay, and that's going to be my next step, is that division. 42 divided by 2 is 21. So this is 15 times 21. 15 times 21 gives me a final answer here of 315. So that is my answer for those first 15 terms, or this sigma notation that I'm given here. I do not have to write out all my terms. I can use the formula now. Okay, and that is the expectation, that we are using the formulas at this point. Again, you could do this long way of finding all of the terms and adding them together. But again, I'm going to start to make these numbers bigger so that that's kind of a hard thing to do. I do want you to be using these formulas. Okay, that is it for our notes today. So really all we talked about are these two formulas. Pay attention to the questions they're asking. They're going to pretty much tell you which formula to use. General rule we use for any missing terms. And then on the back here, our sum formula is if they ask us for a sum. Okay, so pay attention to that as you're working through today's assignment. If you have any questions, let me know. Either shoot me an email or talk to me, and we will figure those out.